Hello my dear students, this is Akash SD and welcome to the SG Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the effect of dielectric on the capacitor. That means how this charge, capacitor, potential, electric field and electrical potential energy will change inside the capacitor. Okay students, so let's start the video and let's learn this very important concept for the board exam and NEET and J exam also. Okay, so see here, we can see very well. See, let Q naught, C naught, V naught, E naught and U naught be the charge, capacitance, potential difference, electric field and electric potential energy respectively when before the dielectric slab is inserted between capacitor plates. That means when only air is there, that time these terms we will use it. Okay, after that let's see. Similarly, let all these things be the charge, capacitance, potential difference, electric field and electric potential energy respectively after the dielectric slab is inserted between the capacitor plates. That means this term we will use when the dielectric is not introduced and this term we will use when the dielectric is introduced. Okay students, so kindly remember this all these things. Okay, now what we are going to see, we are going to see the two cases. In first case, this first case is the default case, that means when the battery is the disconnected. So see here, effect of dielectric when battery is disconnected from capacitor. In this situation what will be there, the charge will be constant. Okay, so students, let's see here, I will draw here one capacitor is there like this. Okay, and anyhow its capacitance how much, C naught here, and it is connected to one battery here, and here potential how much here, V naught. Okay, charge on this how much students, let's see here, the charge on this is the plus Q naught and this side you can write here minus Q naught. Okay, here what is there, the battery is connected and here what is there, air is there, no? And let's take here the terminals A and B. After that what we are going to do here, see, after that what we are going to do, we are going to insert one dielectric here, no? We are going to insert one dielectric of dielectric constant how much, K. Okay, and in this situation what is there, the battery is disconnected. Battery is disconnected. So in this situation let's take potential how much here students, the potential is V. Okay, and the charge how much, charge how much here, let's take here Q and minus Q. So as I have told you very well, what will be same, the charge will be constant here. Okay, so see here the first one, charge on capacitor plates remains constant because battery is disconnected, that means here charge Q naught and here charge how much, Q. So remember that here what will happen, that here this charge, new charge will be equal to Q naught, Q equal to Q naught. That means after the dielectric insertion and before the dielectric insertion what will be there, this charge will be same. Okay, and if we talk about here the capacitor here, na, here C naught is there and here capacitor what is there, C is there, na? So we will see about the capacitor now. Okay, see next one, see next one, see second one, you can see very well, capacitance increases by K times. Why? Because you know very well, when there is no dielectric, this capacitance is given by what here, epsilon naught A by D. After that, when the dielectric is inserted completely, so it will become here what here, K epsilon naught A by D. Okay, and what is epsilon naught A by D, C naught. So here we can tell here students, see, C equal to K C naught here. That means capacitance will be what here, it will increase by K times. Okay, now after that what will happen, that here third one, see, potential difference across capacitor plates decreases by K times. How can we tell this will be decrease? So see here, as you know very well, this Q is equal to Q naught, na? That we know very well. So right here Q is given by C into V, Q naught is given by C naught into V naught, is it? So after that students we can write here, this V is given by C naught by C into V naught, is it? And next one, that means this V is given by, what is C naught by C? You can see from here C naught by C is given by 1 by K. Okay, so overall we can write here V naught by K. That means you can see very well, the potential will become how much here, the potential will become here V equal to V naught by K. Is it? Similarly, next one, let's see here. Similarly, see, electric field between capacitor plates also decreases by k times. How can we tell here? See, again see, as we know very well, V equal to V naught by K, is it? And this V is given by electric field into D, and here also what is there? See, E naught into D by K. So both the sides are D and D cancel. What is D? D is the distance between the capacitor plates here. Okay. So hence we can write here this electric field become here what? It will become here E naught by K. Okay. Great. Now, fifth one, students, you can see very well what is given. Electric potential energy decreases by K times. How can we tell like this? See. So here you know very well, as the charge is constant. So when the charge is constant, which formula we will use? We will use this formula here. U equal to Q square by 2C. Is it? And now what is constant? As the charge is constant, so we can tell U is inversely proportional to C. Is it? So students, when U is inversely proportional to C, what we can write here? See, I can write here C. U by U naught is equal to, inversely proportional means what this will become here? C naught by C. And here you know very well here, C is given by Kc naught, is it? So C naught cancel out. That means here this energy is given by U naught by K. Is it, students? So here all these cases we have covered when the battery is got disconnected. Here all these things we have seen it. Next one, let's see. Case 2. Case 2, in this what will be there? In the question itself they will tell the battery is keep on connected. Otherwise we have to consider disconnected by default. Okay. So see this situation. Case 2. So see. Effect of dielectric when battery remains connected across capacitor. And what is constant now? The potential V is constant. So students, here if I draw here, see, this is the capacitor now here. Now, how much charge is there initially? Plus Q naught, minus Q naught, is it? And here what is there, students, here? Here the battery is connected, how much here? V naught here. Okay, students, and its capacitance how much? Let's take the capacitance is C naught. Okay. After that, what is there, students, here? We are going to insert the dielectric. Now, so see here this. Now, like this here. Now, like this. Let's take this is terminal A and B. Now, because terminal is a very, very important. And here also I have taken terminal A and B. And now what we are going to do? We are going to insert one dielectric here. Completely. Now, dielectric constant K. Okay. And let's take in this situation capacitance how much? C. And the charge. Now, charge. Let's take charge how much here? The charge is here Q and minus Q. And the most important thing is that the battery is keep on connected here. Okay. The battery is keep on connected here. Okay. So see here. First one, students, what is given? Potential difference across capacitor plates remains constant, because you can see the batteries keep on connected. So what will be there, students, here? This will become here V equal to V naught. We are not changing battery and all. What will be there? The potential will be same. Okay, great. Next one, what is happening? See, electric field between capacitor plates also remains constant. That means, students, we can tell here, see, again we know that here, see, as V equal to V naught. So we can write here V means ED and V naught how much here? E naught into D. So both the sides D and D cancel. That means what will happen that here? This E equal to E naught. Again I am telling this D is the distance between the plates. Okay, so electric field is also same. Capacitor increases by K times, as it is. Now, see here already we know that here with air medium epsilon naught A by D, just like a previous. And new capacitance how much here? K epsilon naught A by D here. Okay, so you can write here C equal to Kc naught. Even this K is called what? Dielectric constant or relative permittivity also. Okay, remember that here for air value is 1, for insulator value of K is greater than 1, for conductor K is the infinity. So all these things you know very well here. Now, see here, fourth one, charge on capacitor increases by K times. How can we tell? See, initially if I write here, now before the insertion of the dielectric, so Q naught is given by, you can write here, C naught into V naught, is it? After that, after the insertion of dielectric, this will become here C into V. Okay, so you know very well here, the value of C is given by what here? Kc naught, is it? This C is becoming what here? Kc naught, and the potential is changing? The potential is not changing, V equal to V naught, and you know very well C naught, V naught is what? Q naught. Hence what we can tell, this Q is given by KQ naught here. Okay, the charge will increase by K times. And fifth one, see, electric potential energy increases by k times. So here you can see very well which formula I'm going to use now here. See, we know very well here, see, as no, potential energy, now we are going to use half CV square now, because potential is constant, battery is connected. So from here you can tell U is directly proportional to C. Okay, so students, if I will write here this difference U with the dielectric, U naught without dielectric is given by C by C naught. Is it C by C naught? And you know very well the C means KC naught and by C naught. So C naught cancel. Okay, so students, you can write here U by U naught equal to K, or we can write here U equal to K into U naught. Is it? So this is the scenario for when the battery is connected. Okay, great. Now students, at the end, see here you can see one table is there. No, one table is there. You can see on the first column parameters, on the second column battery disconnected, on the third column battery connected. Okay, so we will fill one by one. So see, if you talk about here, when the battery is disconnected, what is constant here, please? The charge is constant, Q equal to Q naught. Okay, capacitance, anyhow the formula is what? C is KC naught here. Is it? Potential is given by here, see here, V equal to V naught by K. Electric field students also given by E equal to E naught by K. And potential energy is given by what? U equal to U naught by K. So this is the scenario when the battery is disconnected. After that, when the battery is connected to the capacitor and we are inserting the dielectric, so what will happen that here in this situation, what will be same? Potential will be same here. Okay, so we'll see V equal to V naught, and electric field also same, E equal to E naught. Capacitance no change, no? C equal to KC naught, complete dielectric between the plates. And if we talk about the charge will become here Q equal to KQ naught, and this potential energy U will become what here? K into U naught here. Okay students, so now in this video we have learned how this parameters will change when the dielectric will be inserted into the capacitor between the plates, battery disconnected, battery connected. By default, if in the question nothing is mentioned, what you will take when the battery is disconnected. Okay students, so keep studying.